So you will see experiment number 1, truss member with one inclined node, solving using the Ansys Mechanical APDL software. And this is the environment of Mechanical APDL software. And this truss member consisting of 7 nodes, and the loads are acting at node 7, and node 4 is an inclined node. It is making an angle 30 degrees with respect to Z axis. Now we will try to solve this problem using Ansys APDL software, and the dimensions are given in the figure. At node 2 and node 3 there are two loads are acting. At node 2, 3000 Newton magnitude is acting downward direction. At node 3, 4000 newtons of magnitude is acting in the downward direction. At node 7, 6000 newtons is acting in the negative x direction. And in order to solve this problem, first of all we need to select preferences, structural, click OK, then go to preprocessor, element type, and add here link element 3D finite 180, then close. Go to material properties, material models, structural, linear, elastic, and isotropic. Give Young's modulus as 2E5, Poisson's ratio as 0.3. Click OK. Now after giving the material properties, you need to give the area of the link. Go to sections, link, add, and here link 1, give the name as link, and give the area of the link. The area of the link is given in the problem as 120 mm square. I'm giving 120 mm square as the area of the link. Click OK. Then after giving the material properties and giving the area, go to modeling, create nodes in active CS. Node 1 taking as 0, 0, 0 as the reference node, and see the figure. At node 2 is situated distance of 2000 newtons. X is 2000, Y is 0, and Z is 0. Node 3, 4000, 0, 0, click apply. Node 4, it is situated distance of 6000, 6000, 0, 0, click apply. Node 5, it is situated distance of 1000 and 1000, 1000 and 1000 and 0. Then node 6, it is situated distance of 3000, 1000 and 0. Finally node 7, it is situated distance of 5000 and 1000 and 0. Click apply and OK. Then you can see all the nodes. Then we need to create the elements. Select the elements, auto numbered, through nodes. Set each and every node. Join these nodes to form various elements. Now, after joining these nodes, we need to give the boundary conditions for this entire truss member. See the figure at what positions the boundary conditions are situated. Then go to loads, define loads, structural, and you can give the forces on nodes. Select node 2, Fy. The value of Fy is minus 3000. Give minus 3000 newtons. Click apply and select node 3. At node 3, it is also acting in the downward direction. The load value is minus 4000 newtons. And click node 7. It is acting in horizontal negative x direction. The value is minus 6000 newtons. Click OK. Then we need to give the boundary conditions. Select displacement, on nodes, select node 1, click all degree of freedom. Then we need to give the boundary conditions for node 4. In order to give the boundary conditions for node 4, go to modeling, nodes, and nodes, rotate node 4 by angles, give the value of angle as 30 degrees about the z axis. Click OK. Then the node 4 is tilted by 30 degrees with respect to z axis. Then we need to give the boundary conditions for the node 4. Go to define loads, go to the loads, define loads, structural, displacement, on node, select node 4 and apply and constrain that node 4 with respect to uy. Therefore here that is node 4 is a roller support. I am constraining with respect to vertical direction along the 30-degree inclination. Now the entire figure is finished. Now it is ready to solve. Now go to, okay, the figure is finished. Now we need to solve the problem. In order to solve the problem, go to solution, solve, current ls, solve current ls, then click yes, then the solution is done. Therefore, in order to view the results, we need to say go to general post processor, plot results, contour plot, nodal solution, displacement vector sum, click OK. Then you can find the deformation of the entire truss member. If you wanted to view the animation, then you can go to plot controls, click animate the video, then you can observe the deformation of the entire truss member against the loadings. And you can see here the middle member is subjected to severe stresses, and here the maximum deformation is also observed to be 2.72. Okay, now in order to view the stresses induced in each and every member, we need to type set comma L step at the top of the window in the dialog box. Type set comma L step, then after typing go to define table, add, give the value as stress, and by sequence number select ls1. Then again select forces, by sequence number SMISC 1. Stresses can be determined by ls and forces can be determined by SMISC 1. Now close the window. Now after defining the table, go to the plot results, contour plot, line element results, and if you wanted to see the stresses, then select stress and click OK. Then you can observe the deformed shape, how the each member is deformed and what are the stresses induced in each member. You can see what member is subjected to severe stress also. And if you select the line element results and if you select forces, you can observe the forces distributed in each and every member. These results can also be viewed by taking list results option, and you can also observe the nodal solution. If you want DOF solution, displacement vector sum, then the values will be displayed. What are the values at each and every node? Which node is subjected to maximum deformation? You can observe through this window by using list results option. You can also find out the elemental solution also. Okay, this is the nodal solution. And after determining the nodal solution, then go to the elemental solution. You can observe the von Mises stresses distribution in each and every element. The stresses distributed in each and every element can be seen by taking list results option, elemental solution. Reaction forces, all items, click OK, and where the supports are fixed, you can observe at the supports you can observe the reaction forces Fx, Fy, and Fz, and the resultant forces are also displayed. Okay, in this way you can find out the deformations, stresses, forces, and view the list results option. By using the list results option, you can also observe each and every node how it gets deformed against the loading conditions. You can also see the reaction forces also, and you can also observe the animated view of the figure how the deformation takes place in the entire truss member against the applied loading conditions. Okay, you can see the animation figure how the deformation